General networking, network fundamentals, wireless networks. In this video we're going to talk about wireless standards, what's available, how fast a wireless network can go, is it something we can use to replace our wired connections? Wireless network. Wireless is amazing. It's great, it's flexible, it's something that we want to have at home, in our office, everywhere. I remember my first wireless device. It was amazing. I think it was in 1998 that I got my first wireless device. It was awesome. It was great. Here we are. It's 2014 now. And our wireless is, I don't know, 300-400 times faster than it was 15 years ago. More reliable, more secure. Still cannot replace our wired connections. Remember about that. If you want to connect to a wireless network, you need a wireless access point. You need something that will merge, will connect your wired device to a wireless, for instance, laptop. A lot of people ask, what if I want to, I have a big office or a big house and I need 2 or 3 access points. What's the easiest way? Access points can work in many different modes. I found this nice picture on the internet. The most popular, of course, is the access point mode. It means that your end devices can connect. A pretty popular one is bridge mode. If you want to bridge 2 wireless networks, not a very reliable solution, might be tricky. Repeater mode is something that will allow you to extend your wireless network. That's what you can see here, prepared by Linksys in this case. People ask, okay, what's the easiest way? When I connect to this wireless access point, there are a lot of questions. It's not reliable, it's slow. What's the easiest way? Well, the easiest way is, show you that. If this is, let's say, your office, here is one access point, and here is your second access point. The easiest way is to set up these access points with the same SSID, with the same password, with the same security option, let's say WPA2, the same here, the same SSID, the same password, the same security option. It's like, you can even copy the configuration and apply on that one. Make sure you change the IP address. This is your first access point, this is second access point, and then you have your router. This access point is connected with a wire, with a cable, and this one is connected with a cable as well. That's the idea. Now, you should make sure that they should overlap. Let's say this one can cover this area, and this one can cover that area. Make sure that they overlap here. Don't know, 15-20% should be enough. How can I check that? I'll show you some tools. Please make sure you watch troubleshooting LAN and wireless video. There will be some tools that will allow you to do that. Inside there is a tool that you can use for that. Or you can download an application on your phone. However, on a laptop it's more reliable. What you have to remember is that in 2.4 GHz we have 3 clear channels only, 1, 6 and 11 clear channels. I know when you go to your router or your access point, you can go for channels 7 and 9 and 3. We have only 3 clear channels. If you go for channel 1 here, make sure that you go for channel 11 or 6 here. Do not go for the same channel. It will cause a lot of interference. I know when I first saw that many years ago, I said, oh, it makes sense to put them on the same channel, right? Because it is like, you know, it didn't make sense to you. That's not true, really. In wireless, you should not use the same channels here. That's the easiest way to set up your topology. This is your router. If your router is 192.168.1.1, this access point, give it .2. This one, 192.168.1.3. That's it. The same SSID, the same password, the same security option. What's the problem? Well, it will not be... It's not going to be smooth if you move from one place to another. What we mean by that, it's not going to roam. Sometimes the connection can be dropped for a second or something like that. That's why, for instance, you can use a wireless controller that will allow you to roam, or you can extend, you can repeat your signal, but if you do that, you will not achieve the same speed in most cases. That's the easiest solution you can try and deploy, and then if you're not happy and say, no, I'm not happy, I'm on Skype when I walk from one room to another and it drops, whatever, then you can look at some other solutions. Most people are okay. A lot of companies I have seen have 2 or 3 access points in this mode, and that works pretty well. Here is a picture to show you 3 clear channels that we have in 2.4. That's why it makes sense to move 5 GHz, 802.11n, a standard that we have today. The latest one is 802.11ac. Okay, let's talk about standards then. It all started in 1997. It is all described in the standard 802.11, and then they just add letters. And you can think, okay, why is it A, B, G? What happened to H? What happened to, you know, X or whatever? Well, sometimes, you know, they have an idea and they drop it or leave it and they move to the new draft, new project. The same applies to IPv4 and IPv6. There is IPv5, and you know, it could be IPv15. It doesn't matter. It's just a name. As you can see, we started 2 megabits per second. That's what we had many years ago. Today we are over here. Well, that is in theory that 802.11ac will allow you to achieve gigabit speeds. Let me show you a graph that I found. It's that one. 802.11n, most access points that people have today at home, that is 802.11n. They will give you between 50 and 80 megabits per second. More than enough to browse the internet, more than enough to stream HD video. That's all we really need. Of course, today it is 802.11ac, a standard that, well, I have seen a lot of new routers. Of course, it's, you know, it's, oh, I can have the fastest one, the best one. They're really expensive. They're really fast. Yeah, that is, first of all, do not trust what you see on the internet everywhere. Some companies and places, it's you know, well, yeah, I will not mention any names. That's all I have to say about that. Be very careful when you Google and see some reviews. Some of them are sponsored by a company. That's all I have to say about that. And then you take it back home and you get like 20% of the speed that you saw online and say, what's wrong with this thing? Well, there is nothing wrong. Someone just paid some money to make it happen. 802.11ac, as you can see, we can go at the moment around 300-400 megabits per second. And you know, you have to pay at least £200 for a good router that will support 802.11ac. You will not find a single device that has a built-in card for that. It means you have to upgrade all your devices. That is like 50-60 pounds for a USB card. For a laptop, maybe you can buy a card as well. A lot of money. You will spend 500-600 pounds to upgrade all your devices. Of course, your phone will not support it either. Think twice. Maybe it makes sense to wait 6-8 months and pay 80 pounds for a router like that. Do we really need that? That is a question that, I appreciate there might be a place where you need 400 megabits per second, but remember, take it easy. Yeah, it's not that important if you use your wireless to browse the internet and download a movie from your NAS server. That's what you can see here. That's almost 100 megabits per second. In most cases, that's what you need to stream the best, to stream a movie to your laptop anyway. Of course, it's good to have 500 megabits per second. I am not happy to pay 300 pounds for an access point. I don't really need that. In this video, we talked about wireless networks and wireless standards. The last thing I want to discuss is how is it possible that we can achieve all these speeds? What has changed in the last 15 years? Well, of course they tweaked and changed a lot of things in wireless standards, but what they introduced a few years ago was MIMO or MIMO, M-I-M-O, multiple input, multiple output. It means that we can take advantage of multiple antennas and we can send and receive at the same time to improve our performance. And it is implemented in 802.11, WiMAX 4G. We can take advantage of that, and that's why you can see 400 megabits per second. Of course, there are more features that they implemented, especially in 802.11 AC. I encourage you to read about that if you're interested. Thank you very much.